Alright everybody, well we get quite a few questions, or at least we see a lot of questions brought up about the older machines, the older Fanuc controls. This is a 6T on an older Nakamura Slant 1, and I think this machine was made in '85, so we got this one as a sister machine to our little G50 over there, and it took us a while to get this thing going based on the O control, which is on the TMC, versus the 6 machine, or the 6 control that's on this machine. And the programming that was on here used G50 grid shift for the existing programs that was on here, and it led to a lot of crashes and a lot of confusion sort of on my end. So going through all the manuals and reading what G50 does with the grid shift, trying to find origins and all that, it was frustrating because not only do you have to post out post out code one way, go in, change it, change all of your tooling offsets or your commands when you call a tool change for your X and your Z, it became really annoying. One of the other big things on this machine is X was negative when you go to a larger diameter, so we actually got a hold of a Nakamura tech, switched all that around, and now everything is X normally this way is positive diameter and this way is negative, but from the factory these were reversed, so arc calculations and all sorts of stuff wasn't doing what it was supposed to be doing. So we got that remedied. As you can see, this machine runs parts just fine. We actually took the hydraulic chuck off of this and put a standard 8-inch 3-jaw chuck on here because we do so much prototype work. We don't do a lot of production runs. These pulleys, for example, I'll make maybe 20 or 30 at a time, and then I won't make them for a year. And then I'll make another 20 or 30. So lots of in and out, lots of non-repetitive work, lots of one-offs, different pulleys. These are some blanks for some other pulleys, things like that. And yeah, so that just made it easier for us to not have to go in all the time and edit G-code. Now at this machine, we do have a PC hooked up with an RS-232, and we do have NC link on this computer, so we can go in, edit code if we need to, and then re-shoot it over. This control does not support drip feed, so we are still limited by the machine memory. So we generally only run one program at a time. Since they're pretty long, they have a lot of arcs, things like that. So this machine was homed last time we turned it off, and we have to, obviously we just turned it on. It's still in e-stop. We'll get it everything activated, and my screen has been starting to get wonky here. The funny thing is if I unscrew the door and I open the door and close the door, it comes back on. So I think I got a loose wire somewhere that I have to diagnose. But so we're going to go to position. Oh, maybe I should leave this unscrewed here for the video. There we go. So we're going to go to our XZ position. We're going to go over to 0 return, lever out, and then we're going to do our Z return, or sorry, our X return. And obviously it's going to be a little off from when the machine sags when everything gets powered down. And we're not that far off, but we're going to go X. It's flashing. We're going to hit origin. We're going to hit Z and origin, and now everything is basically zeroed out. So if we go over to our multi-view page, everything is now zeroed out. So as you can see, I've got some notes up here for different numbers for different parts and all that, and we're going to get to that later. So we're going to index our turret, and even though we don't have a hydraulic chuck in here, we still have to make sure that the chuck's closed. So chuck is closed. And then now if we want, we can, warm the spindle up, whatever, just using start, stop, reverse, all that. So now if we go to our offset page here, So we've got these are our tooling offsets. And alright, so we had an interruption here on the video. I'm going to have to merge these together, but we've got our our tool offsets here. We've got 2 pages of them, obviously, because we've got 12 turrets and 12 turret spindle, or a 12 tool turret, and I can't talk today. We've got multiple pages, so we can call different offsets if we want to. So I can call tool number 1 offset number 15 if I want, but we don't really need to use that very often. So if you'll notice, all of our X offsets are a negative number, and they're all fairly large. If we have a dead tool or we don't have a tool in the turret, I'll put a positive number. That way, if I do end up accidentally calling that tool, it will over travel the machine and alarm out so that it doesn't try to crash. So our Z offsets here are the distance from our master tool, which is our tool number 1, the distance in Z from the tip of our master tool to the tip of whatever tool it may be. So for example, so tool number 1 is our CNMG 80-degree right-hand standard, roughing tool that pretty much the whole industry uses. And if we go up to, say, we'll go tool number 4. Tool number 4 is a threading tool right here, and if you look at it, we're 1.4 inches roughly longer, and that's what we have in our tool table. Now we've got some larger numbers here, so tool number 6 and tool number 8 are our big drills. So we've got a 1/2 inch drill and a 1 inch drill, so obviously they're going to be quite a bit longer, as well as tool number 11, which is our boring bar down here. So that's our distance from the tip of this tool to the tip of this tool, or the tip of this tool to the tip of this tool, etc., etc. So the distance in X, this distance here, is the distance from when the turret is at home to the distance to where the tool is at the center line of the part. So that's for tool number 1, we've got 14.5 inches exactly, and it's funny that that actually worked out like that. But it'll go 14.5 inches. Remember, we're working in diameter here, so 14.5 inches, if we were to actually swing something right now, it would be 14.5 inch diameter at this location. So to get to our X0, we have to come down 14.5 diametrically to get here. Same thing with all the other ones. Some of them are bigger, some of them are smaller. So for example, tool number 11 is actually further than that because it has to travel over center. We'll turret this around here. So this has to actually travel further so that the center of this, or the cutting surface of this boring bar, is actually lined up with our spindle center line. And same thing with the drills and all that. You just have to figure out, normally we'll do a test cut, measure it, see how far we've gone, plus what our cutting diameter is, whether it's an ID or an OD, and then from there just add those numbers together, and those go in our X offsets. Same thing for setting our Z offsets. We'll skim a part or skim a piece of scrap with this. We'll set our 0, and then rotate the turret around, touch off the next tool, and set that Z number. So the radius and tool orientations on these, we don't use them most of the time because we use software comp to do it rather than machine comp, since this machine's pretty old and we try to have it do the least amount of math physically possible just for that case. So I'll show you how I touch off on a part, and I'm going to try and do this with 2 hands holding a phone at the same time. So we're going to go back to tool number 1 on our turret, and if we go back to our position page, we're still zeroed out. I'm going to try and back up here. So I'm going to grab this, and I'm going to come down to where we're going to get close. And I'm going to get close. I'm not going to touch off completely, but I'll get you the general idea. So basically we do a paper touch off, 2 or 3 thousandths, and we'd come up here and we'd say, okay, now we've come down X amount. Our X offsets are done in the tooling offsets, so we don't ever have to zero out our X, because if you zero out your X, you mess with the center line calculations of the part. Now this is our number that we had the other day, our 5.489. You know, obviously we're a little bit shy because I'm not touching off completely right now. But if I was going to set this to my part origin, I would just go Z and origin. And now the machine knows where my 0 point is. So I'm going to zero return this again. And we'll come back and we'll go through the program and show you what the program looks like that we would run on here. And then we'll do a couple MDI things and from there. So we're gonna go over to edit. This is our program number. We keep everything pretty much on program 100, which is what it posts out as, and we never have to change it because we usually only run one program at a time just based on our memory. So this particular machine has a single speed gearbox, but it won't activate the spindle unless you give it an M41. If you give an M42, it won't do anything. If you leave M41 out, it won't do anything. You have to have an M41 on this control for it to actually recognize an M3 command, which is strange. It took me a lot of figuring out, reading the manuals, trying to figure out why when I first bought it, it wouldn't turn on. But anyways, so G28, U0, W0, that's obviously incremental for go home or return to reference point. Don't use X and Z or you'll crash. And then we've got our M3 S500 with our speed limit down here at, so we've got surface speed, we've got our surface speed and our 500 inches a minute. And then we've got our G50 S1000 for our RPM speed limit on the spindle. And then we'll call tool number 1, but offset 0. So this will rotate the turret to the right tool, and we'll turn the coolant on. And then in our first motion, so we'll rapid to 1 3/8 over in Z, and then slightly larger than our bar diameter, which is 3 inch, to our initial point, and then we'll call our tooling offset. And what that'll do is it will look at where the turret is now, look at where it needs to go, and then look at our offsets page and do the math and say, okay, we're going here, but we have our offsets as this. We need to travel this far to satisfy this motion, and then from there it'll continue down and run the rest of the program. So if we go into MDI, and I have to go to MDI, here we go. So if I go, I'm going to go tool, we'll go tool 400, and I'll hit input, and we'll hit start. I'm going to turn rapids all the way down, so I'll hit start. Oops. Input. Oh, that's why. I was on edit instead of MDI. There we go. Tool 0400, input. There we go. And hit start. It will rotate the turret, and that's it. Now, if I want to call the next tool, so we're going to call tool number 5, which is our pulley cutting VNMG. We have our rapid set on low, so we're not going to crash anything. But watch what happens if I go tool. If I go 0505 input, and if I hit start, watch what the turret does. So the turret wants to move until it satisfies. I'm going to hit reset so it doesn't crash. So it will try to move the amount that's in the offset. So it's going to only move 644 negative in Z. So it's going to try to match the same number here as our master tool, and then it's going to come down to 1209 negative in the diameter. So it's going to come down to the center line. And obviously if you're doing something where your part could get in the way of that, you don't want to call that at the same time. Or if you have your rapid set, you know, to 100% and the turret moves fast enough, the turret could still be moving while, or sorry, the turret could be moving in X and Z while the turret is still rotating. So we generally will have it set up like this, where it will rotate the turret to its position and then do the math. So there's no G50 grid shifts, copy paste numbers, all that. It's way easier. And then the same thing for the next tool. So You know, tool number 5, we call tool 5, we turn the coolant on, we set our spindle RPM up here on the previous line. You know, we're running in constant RPM now, we're not doing surface feed anymore. And so we're giving it a 1200 RPM, and then tool number 5 on the turret, and then in our first move, tool number 5 with the offset. So, and we've ran thousands and thousands of parts this way. The only, I guess, downfall of running it like this is when we go to our offsets page, there is no wear offsets. So any finagling that you have to do to change something by a couple thousandths, you actually have to do in here, which is a lot easier math than having these all written down somewhere, have to go into your G code, copy and paste the G50s, hopefully have the right, you know, positives, negatives, or, you know, make sure you didn't change a tool and, you know, weren't paying attention. We have never crashed this machine, and, you know, knock on wood, you know, we've never had an issue with doing the way that we do. I know there are some people that want to do it the proper way, you know, running it in G50 in grid shift. It just seems like a lot of extra work, you know, for no reason. You know, unfortunately, if this machine, actually, we'll go over to our O machine real quick. And sorry, the shop is quite a mess here. We're actually getting ready to move. We'll go over to the O machine. I'll show you guys. This is very important. Same thing here, these all have computers hooked to them, so we can load stuff over. All right, so this machine, if we go into our offsets, now we've got a wear offsets page, we've got a geometry offsets page, same deal. Tool number 1 is our master tool in Z. All of our X distances are the distance in X diametrically that it has to move. This machine obviously isn't very big, so the numbers aren't very large. And then we've got a work shift. So the work shift is what we set our Z in. So we'll skim off with tool number 1, since tool number 1 is a 0 on the Z. We'll come in, we'll skim off the face of our part, look at how far the turret had to come over to skim that off, and in this case it's 6.311. So we'll type that in, and then the machine knows how far over the origin is from when the machine is homed to where the front of the part is that we're running, and then we can run whatever parts we want. If we go into program here, we'll go into edit. So this one we call in the traditional way, so we've got a return to origin, and then we've got a traditional tool 1 offset number 1 with our G50 just for our speed limit, so it doesn't do grid shift or anything like that. But obviously this is a O control, which is quite a bit newer and has a lot more features. So hopefully that answered some of your questions. Maybe it confused you even more, but this is the way we do it, and it's worked out quite well for us in the past. This machine, we've actually crashed this machine once and broke the lens, not from a programming error, but from a part getting kicked out. So it goes to show you you can mess up even if you're being careful. So anyways, hope that answered something, and yeah, happy chips.